So this video is going to be an overview of the different chemical reaction types that you have to be familiar with. I have more details of all of these videos in my Chemistry 1025 Module 6 videos, where I have a video for each reaction type individually. So the first chemical reaction type I want to go over are called the precipitation reactions, also known as double replacement reactions. So precipitation reactions occur where a solid forms when you mix two different aqueous solutions. The solid which forms can be called a precipitate. So here's an example where we mix potassium iodide with lead 2 nitrate, and notice the formation of this yellow material, this yellow solid. That is called a precipitate, and this particular yellow solid is called lead 2 iodide. Now in the solution, we're also going to form potassium nitrate, but that is water soluble, so we're not going to see anything forming. But the yellow stuff here, that's going to be the lead 2 iodide. Now, if you happen to mix two liquids together, two solutions together, and you don't see anything forming, even though it might look like it's a precipitation reaction, if you don't see anything forming, in actuality you have no reaction. So for this to occur, a precipitate must occur as one of the products. Alright, so basically these are some the rules we're going to follow. It's actually easier just to go through a couple examples. Alright, so let's say you want to mix potassium iodide with lead 2 nitrate. Let's see how we figure this out. What we do, we have to look at the charges of the potassium and the charges of the iodine. So in Ki, the charge of potassium is going to be +1. The charge of iodine is -1. The charge of lead is +2. The charge of nitrate is -1. So basically what's going to happen is that lead can combine with potassium can combine with nitrate, and lead can combine with iodine. So we can get K goes with NO3, K goes with NO3, and Pb goes with I. So how do you find the subscripts? Well, if K is +1, NO3 is -1, because the charges cancel, so we just make KNO3. Now, let's see now a case of lead and iodine. Pb is +2, iodide is -1. The charges don't cancel, so hence that's how we get PbI2, because we need two iodines to make the cancel out. So that's how we predict the products. Basically, the cation from one of the reactants combines with the anion of the other. So K goes with NO3 and Pb goes with I to figure out what we can possibly make. Once you figure that out, now we have to check the solubility chart to figure out which one of these is water soluble or not. Let's take a look at let's see one of these examples here. Let's work through the one in the middle. K2SO4 with AgNO3. So what do we form? So K combines with NO3, Ag has to combine with SO4. As cation with anion, cation and anion. Now the K is in group 1 in the periodic table, so it's +1. NO3, that's in the polyatomic ion chart, that is -1, so that you need to know. So notice these cancel, +1, -1, they cancel out. The charges cancel, so it's just going to be KNO3. Now the other possible product is going to be Ag with SO4. Silver is +1. SO4, that's on the polyatomic ion chart. They have that memorized. That is -2. So do these charges cancel? They don't. So we're going to crisscross the charges. So we're going to get Ag 2SO4. I need two silvers to cancel the negative charge of the two negative of the sulfate. All right, now that's the first thing we do. We predict the products. Now, once you've done that, now we're going to basically figure out. We have to balance the equation. So this equation balance. We have 2 potassiums on the left. I have 1 potassium on the right. So I'm going to put a 2 in front of the KNO3. That balances the potassium. Because we did that, then I'll change the number of nitrates. Now I have 2 nitrates on the right, so I put a 2 in front of the silver nitrate. They gave me 2 silvers. That matches my 2 silvers. I only have 1 sulfate. I have 1 sulfate. So now the equation is outbalanced. Now we have to check. Now we have to figure out which one of these is water soluble. So I have an earlier slide where it shows the solubility rules for this, which you need to have memorized. And I have memorized that all alkali metal salts are water soluble, as well as all nitrates. So I know potassium is water soluble, so I know this has to be potassium nitrate has to be AQ. Now, silver salts are commonly not water soluble, and neither are sulfate salts. This is going to be my solid. So now we have what's aqueous and what's solid, and my equation is all balanced. So this is called the molecular equation. Now, as customary, you write what's known as the complete ionic equation. So what we have to do, whatever is water soluble, whatever says AQ, we're going to split up into its ions. So in this example here, if you look at this here, this KOH, it means I can split up K, I can split up OH. For magnesium nitrate, I can split up magnesium, I can split up nitrate. For potassium nitrate, I can split up K, I can split up nitrate. The solid, we leave alone. We don't split that up. So we end up getting the 2 here. We're going to multiply the coefficients times subscripts. So 2 times 1 KOH, 2 times 1 OH, 1 times 1 Mg, 1 times 2 NO3s, 2 times K, and 2 times 1 KNO3. Now when you do this, keep in mind polyatomic ions are groupings. This is like, wrong color. So keep in mind that these polyatomic ions, you can group this NO3 here as one thing. So it's like saying 2 times 1. Okay, likewise over here, it's like 2 times 1 OH. Now the solid magnesium hydroxide, we leave that alone. So when we do all this, for this particular example, we end up getting this here. We get 2K plus aqueous plus 2OH minus aqueous plus Mg, 2 plus aqueous, and so on. The solid we leave alone. So we're going to do the same thing down here. Whatever's water soluble, we're going to split up. So 1 times 2, so it's 2K. K has a positive 1 charge, aqueous, plus SO4 negative 2 aqueous, plus 2 times 1 silver, so it's 2 Ag plus aqueous, plus 2 NO3 minus aqueous. Notice it's not 6, because nitrate is like one group. Arrow, repeat over here, 2K plus aqueous plus 2 NO3 minus 1 aqueous, and the salt we leave alone. Ag Ag2SO4 solid. So you must write the AQs, you must write the solid at the end. This is called the complete ionic equation. That's the complete ionic equation. Now to write the net ionic equation, what we have to do, we have to cancel out the spectator ions. So whatever's in common on both sides. So I have 2K plus, 2K plus, 2NO3 minus 1, 2NO3 minus 1. I'll recopy the rest of it down. 2Ag positive AQ plus SO4 negative 2AQ arrow Ag2 SO4 parentheses solid. That is called the net ionic equation. The things I crossed off, those are called the spectator ions. They're called the spectator ions. Let's try this example. Sodium chloride with lead 2 nitrate. So sodium chloride is NaCl aqueous plus PbNO3, that's nitrate. That lead, room number 2 means it's positive 2, nitrate's minus 1. Crisscross that, parentheses 2 aqueous arrow. Just remember it's going to be cation sodium with NO3 and lead with chlorine. So Na with NO3. Recall that sodium is plus 1, nitrate's minus 1, so they cancel out. I know sodium salts are water soluble, so I know that's going to be aqueous. Plus. Alright. Pb goes with Cl. Now lead is a positive 2 charge. Chlorine's a minus 1 charge. So crisscross. Pb1, Cl2, Cl2. Lead salts are typically not water soluble. Lead chloride I know is not water soluble from the solubility chart, which you should have memorized. That means that is S, solid. Alright, so now I'm just going to balance the equation. So we've got 2 chlorines on the right, therefore I need to put a 2 in front of sodium chloride. Since I put a 2 in front of sodium chloride on the left, I have to put a 2 in front of sodium nitrate on the right. It gives me 2 nitrates on the right, I already have 2 nitrates on the left, and we have 1 lead on both sides, so now it's all balanced. Split up the ions. 2 sodiums, 2 Na plus 2 Cl minus is all aqueous, plus Pb positive 2 aqueous plus 2 NO3 minus aqueous, arrow 2 Na plus aqueous plus 2 NO3 minus aqueous plus PbCl2 solid. So whatever the precipitate is, we leave alone. Don't forget to copy the aqueous and all that stuff. Cancel off what's in common. 2 sodiums on both sides. 2 nitrates on both sides. Now recopy what's left over. And I always like to copy the positive one first, but that's up to you. Pb positive 2 aqueous plus 2 Cl minus aqueous, arrow PbCl2 solid. That gives us now our balanced molecular equation, complete ionic equation, and our net ionic equation.